So let's read the question. BE and CF. So BE and CF are two equal altitudes of a triangle ABC. So the altitudes of a triangle ABC. Using RHS congruence rule, prove that the triangle ABC is isosceles. So first of all, understand the question. What are we given? Here we have a triangle ABC. Here BE and CF are two equal altitudes. So the moment I see equal altitudes, mark them. That is BE is equal to CF. So here we're given that B and CF are two equal altitudes. Now what do we have to prove? We have to prove that triangle ABC is an isosceles triangle. What is an isosceles triangle? A triangle in which two sides are equal. So basically we want to show in this triangle two sides are equal. So how can we show it? Recall, whenever you have to show two sides in a triangle to be equal, recall the converse of the theorem. That is, in a triangle, if two angles are equal, sides opposite to them are also equal. Recall, we have studied this theorem. That is, in a triangle, if two angles are equal, then the sides opposite to these equal angles are also equal. So basically, if I can show in this triangle two angles to be equal, our job is done, right? Now, how do I show that? We're given a hint in this question using RHS congruence rule. RHS congruence rule is used only in the case of right angle triangles. So simply look for right angle triangles. So see, this over here is a right angle, this over here is a right angle. So what are the right angle triangles? BEC and BFC. So let me highlight them. So this over here is one right angle triangle. Similarly, this over here is another right angle triangle. So BC over here is a common base, right? So if I can show these two right angle triangles to be congruent, then what will we get? We'll get angle B is equal to angle C. The moment I get two equal angles in a triangle, sides opposite to them will also be equal. So that is a thought process. So now let's begin. So which two triangles are we taking? Triangles BFC and triangle BEC. So in triangle BFC and triangle BEC. So we basically have to show these two triangles to be congruent by RHS criteria. So first begin with the right angle. This angle and this angle both are equal, both are 90. So angle BFC is equal to this angle, angle BEC, which is equal to 90 degrees. What is the reason behind this? This is given to me. So write in bracket, given. Next, what are we given? So always begin with what is given to you. Next, we're given that BE and CF are equal altitudes. So BE is equal to CF. So I'll write over here, BE is equal to CF. Again, this over here is given to us. So first step is always use whatever is given to you. So BE is equal to CF. Now if I look at the RHS criteria, this over here is R. What is BE? See, in each of these right angle triangle, locate the hypotenuse. For the blue triangle, which is the hypotenuse? BC. For this red triangle, which is the hypotenuse? BC. So basically BE and CF are sides. This is S. So what about the hypotenuse? Like I said, the hypotenuse for both the triangles is BC and BC is a common side. So BC is equal to BC. So BC is equal to BC. What is the reason? Common side. So first begin with what is given to you and then based on what is left, see. So basically one right angle inside I have. What is remaining? The hypotenuse. In this right angle triangle, BC is the hypotenuse. In this right angle triangle, BC is the hypotenuse. How do we locate it? Side opposite the 90-degree angle. Side opposite to this, BC. Side opposite to this, BC. So in both the right angle triangle, the hypotenuse is the same, right? So basically we have done the RHS criteria. Right angle, hypotenuse, side. Therefore the two triangles are congruent. So this implies, now be very careful when writing the congruence statement. So let's say I begin with this, B is equal to CF. So I'll say triangle BE is congruent to triangle CF. Now be very careful over here. See, angle BFC is equal to angle BEC. Basically angle F is equal to angle E. I repeat, angle F is equal to angle E. See if that is coming from your congruence statement or not. So 1, 2, 3, 1, 2, 3. So I want angle F is equal to angle E. So F is over here, second letter will correspond to second letter. So angle F is equal to angle E, correct. B, first two letters correspond to first two letters, CF, correct. Next, what remains over here? BEC. What remains over here? CFB. Now, BC should correspond to BC. BC's first and third letter here. This will correspond to first and third letter here, that is BC. See, BC, CB, same thing. I repeat, see, get the side corresponding to BC. BC is what? First and third letter here. This will correspond to first and third letter here. Again BC. So all the three things are matched. I repeat, BE first two letters is equal to first two letters CF. Angle E is equal to angle F and BC is equal to BC. So this is the congruence statement. What is the criteria we've used? RHS. So you can write over here, RHS congruence rule. So basically using the RHS criteria, we have shown these two triangles to be congruent. Now what do we want? We basically want to get angle B is equal to angle C. So let's get this from the congruence statement. Search for B in the congruence statement. It is the first letter. So first letter will correspond to first letter over here. That means angle B of this triangle, that means this entire angle, is equal to angle C of this triangle. Right? So basically therefore angle FBC or simply angle B is equal to, now see there are two things over here, so it might be confusing, so just let's put FBC. So therefore angle FBC is equal to this angle, angle ECB. I repeat, how did I get it? See, first letter corresponds to first letter, so B corresponds to C. That means angle B of this triangle, triangle BEC. So what is angle B? So we have shown the two triangles to be congruent by RHS congruence rule. Now what do we want? I basically want to get these two angles. So using RHS congruence rule, we have basically shown these two triangles to be congruent. That is triangle BEC is congruent to triangle BFC. Now what do I want? I want these two angles to be equal. That is, I want angle B to be equal to angle C. How do I get it? From the congruence statement. So see, search for angle B for triangle BFC. This is triangle BFC. Search for angle B. B over here is third letter. I repeat, see, I want angle corresponding to angle B. So for this triangle, triangle BFC or CFB, this is angle B. What is B over here? Third letter. So this will correspond to third letter here. That means angle B of this triangle corresponds to third letter here, angle C of this triangle. So we have it over here. So right over here, therefore angle FBC is equal to angle ECB. That is angle FBC, this entire angle, is equal to angle ECB, this entire angle. How? CPCT. Corresponding parts of congruent triangles. Now the moment you get these two angles to be equal, now look in triangle ABC. So basically now I'll say in triangle ABC, we have, let's say I call this over here 1. So in triangle ABC, we have angle B is equal to angle C. Why? We just showed it over here. So I'll say from 1. The moment in a triangle, two angles are equal, that means sides opposite to them are also equal. So I'll say this implies, what are the sides opposite to angle B and angle C? Side opposite to angle C is AB. Side opposite to angle B is AC. So AB is equal to AC. What is the reason? In a triangle, sides opposite to equal angles are equal. So let me write it. So remember this theorem. In a triangle, sides opposite to equal angles are equal. This implies AB is equal to AC. That means the triangle is isosceles. So therefore, triangle ABC is isosceles. Hence proved. So this is how you solve this question. So let me do a recap. The first step is always begin with what is given to you. We are given B and CF are two altitudes which are equal. Now we have to show that triangle ABC is isosceles. So the first thing that comes to your mind is, what is an isosceles triangle? A triangle in which two sides are equal. So if I have to show a triangle to be isosceles, I have to show two sides to be equal. How can I show in a triangle two sides to be equal? Right? Simple. In a triangle, if two angles are equal, sides opposite to them are also equal. So if I can get two equal angles in this triangle, my job will be done. Now the hint given to me in this question is using RHS congruence rule. So where can I apply RHS congruence rule? In right angle triangles. So I saw these two right angle triangles. So I checked, are these two triangles congruent? Begin with what is given to you. Right angle is equal, one side is equal. Next, is the hypotenuse the same? Yes, hypotenuse for both the triangles is the same, BC. So by RHS criteria, the two triangles are congruent. The moment these two triangles are congruent, I get angle B is equal to angle C. Now in a triangle, if two angles are equal, sides opposite to them are also equal, right? So this is how you solve this question. So just understand what is given to you, what you have to prove, go step by step, you'll get the answer, right? So this is how you solve this question.